Welcome to Sleepy Scientific Secrets, a quiet corner where we leave the noise of the day behind and gently uncover the hidden wonders of our world. Tonight, we begin a fascinating exploration. You might like to imagine that as you settle into stillness. The universe continues its slow work without needing attention. One quiet idea drifts beside us now. Dark matter makes up most of the mass of the universe. It does not shine. It does not reflect light, yet its gravity gently guides galaxies as they turn. Like an unseen current beneath the calm water, it shapes motion without ever revealing its face. You do not need to see it to feel its presence. Much like the quiet weight of night around you. As galaxies spin, they move faster than visible matter alone can explain. Stars at their edges should drift away. They do not. Dark matter forms a wide, invisible halo, holding each galaxy together in a patient embrace. I like to think of it as a soft gravity blanket, keeping ancient lights from wandering too far. Perhaps you have felt something similar. A quiet force that keeps your thoughts from drifting as sleep approaches. This unseen matter does not clump like stars or planets. It passes through itself, through light, through us. Billions of dark matter particles may be moving through your body each second, leaving no trace, no sensation, just passing like a silent thought. There is something comforting in that idea, that the universe can move through you without asking anything in return. If tonight's exploration felt like a peaceful escape, you can let me know with a like or stay longer by subscribing. Either way, I'm grateful you're here. And if you feel like sharing, I'd love to know, what quiet corner of the world is listening along? Over long stretches of time, dark matter helped form the first structures in the universe. Before stars learned how to glow, before atoms gathered into familiar shapes, it created gentle wells of gravity, places where matter could rest. In a way, everything you know grew inside those invisible cradles. Even now, you are sitting within a pattern that began before light had a memory. Some scientists think dark matter may slowly decay, releasing faint whispers of energy across cosmic ages. Nothing sudden, nothing loud, just a gradual soft change. Like the way night slowly becomes morning without anyone noticing the exact moment. It reminds me that even the most mysterious parts of reality are patient. And perhaps, as you rest here, your own thoughts can follow that same quiet rhythm, drifting onward into deeper calm, as the unseen universe continues its quiet work around us. Dark matter does not interact with light, but it does respond to gravity with great sensitivity. When two galaxies slowly approach each other, it is dark matter that reaches out first. Its vast halos meet long before any stars come close, like distant shorelines sensing the tide before the water arrives. This early connection helps decide how galaxies will eventually merge, perhaps like thoughts that meet softly before words ever form. As these halos overlap, they begin to stretch and reshape. Computer simulations show long dark matter streams forming between galaxies. Invisible bridges that guide gas and dust toward new regions of creation. I imagine these bridges as faint paths in the dark, not meant to be seen, only followed. There is something gentle about guidance without force, direction without pressure. a reminder that movement can be slow and kind. In massive galaxy clusters, dark matter gathers more densely than anywhere else. When light from distant galaxies passes through these regions, it bends. This effect is called gravitational lensing. Astronomers use it to map dark matter by watching how background light curves and stretches, like seeing wind by watching leaves move. We never see the wind itself, yet its presence becomes undeniable through its quiet influence. In moments of rest, you may notice something similar within yourself, a shift without a sound. Some observations suggest dark matter may not be perfectly smooth. Tiny clumps could exist within its larger halos, small pockets of extra gravity drifting through space. These clumps may subtly disturb stars and gas as they pass, creating ripples that take millions of years to unfold. It is comforting to think that even the most stable systems allow for softness, for small imperfections that add texture to the whole. There's also the possibility that dark matter interacts faintly with itself, not enough to glow or collide like ordinary matter, but enough to slowly redistribute energy over cosmic time. This could explain why some galaxy centers appear less dense than expected, as if the darkness itself is learning to spread out and rest, like a long-held breath finally easing. All of this unfolds continuously, without sound, without urgency. Dark matter keeps shaping the universe in ways that remain mostly hidden. And as you remain here in this quiet moment, you are sharing space with forces older than stars, moving gently, patiently, carrying the deep rhythm of the cosmos forward into stillness. Carrying the deep rhythm of the cosmos forward into stillness as that motion continues far beyond what we can notice. Within this vast quiet, there is another gentle truth. Dark matter helped determine where galaxies formed in the early universe. After the first moments following the Big Bang, regions with slightly more dark matter pulled in ordinary matter more effectively. Gas flowed inward, cooling slowly, until stars could finally ignite, like dew gathering in shallow hollows before dawn. Structure began where gravity whispered first. As time moved on, these early patterns remained. Even today, galaxies are arranged along enormous filaments of dark matter, stretching across hundreds of millions of light years. This structure is sometimes called the cosmic web, a network of invisible threads connecting clusters and voids. I like to imagine it as a quiet scaffolding, holding everything gently in place, allowing light to decorate its shape without ever revealing the frame beneath. Inside this web, dark matter continues to drift. It moves slowly, responding to gravity over immense spans of time. Unlike stars that orbit in clear paths, dark matter follows broader motions, more like a slow tide than a current. This slowness allows galaxies to remain stable for billions of years, a reminder that patience can be a powerful force. There are places in the universe where dark matter is sparse, vast cosmic voids where galaxies are rare. These regions expand faster than areas with more mass. Space itself stretches more easily where gravity is weak. In these quiet expanses, light travels long, uninterrupted distances. I imagine them as deep pauses between thoughts, necessary spaces that allow the whole pattern to breathe. On smaller scales, dark matter influences the motion of satellite galaxies. tiny companions orbiting larger hosts like the Milky Way. Their paths reveal how mass is distributed far beyond visible stars. By tracking these motions, scientists can estimate the shape of our own dark matter halo, a vast, unseen presence surrounding our galaxy, extending far beyond its shining arms. It is comforting to know that even as our planet turns quietly through night, it is held within something much larger, something steady, something ancient, still guiding motion without sound. Still guiding motion without sound as that unseen presence remains wrapped around everything familiar. Within our own galaxy, dark matter sets the speed at which stars orbit the center. Far from the bright core stars move faster than visible mass alone would allow. Their steady motion reveals a deep reservoir of gravity extending well beyond the glowing disk. Like hearing footsteps in an empty hallway and sensing someone is there before you ever see them. The galaxy feels fuller than it appears. This hidden mass also affects how galaxies respond to collisions. When two galaxies pass through each other, the stars rarely collide. Gas clouds can crash and heat, but dark matter halos pass through almost untouched. Observations of merging galaxy clusters show the dark matter separating from the glowing gas, sliding ahead quietly, as if the universe briefly reveals which parts are solid and which are only light. It is a soft reminder that not everything important leaves a mark. Deep underground and far from city noise, delicate experiments listen for dark matter here on Earth. Detectors filled with liquid xenon or germanium wait for the faintest interaction. A tiny flash, a slight vibration. So far, nothing certain has arrived. Yet the waiting itself is part of the science. Years of silence refining what dark matter cannot be. Like sitting in the dark, letting your eyes adjust. Learning from what remains unseen. Some theories suggest dark matter could be made of ultralight particles, so light they behave more like waves than points. In this picture, dark matter forms gentle ripples on galactic scales, smoothing out sharp structures, creating soft cores instead of dense peaks. It feels similar to the way sound fills a room. No single place holds it, yet it is everywhere at once. There is also the idea that dark matter may slowly annihilate when particles meet, converting mass into faint radiation. If this happens, it would be most noticeable where dark matter is densest, near galactic centers. Telescopes search for subtle excesses of energy there, listening for a whisper within the noise. Whether or not it is found, the search continues calmly, because the universe does not rush its answers. And as all this unfolds above and around you, the quiet gravity of the cosmos continues its steady work, holding paths, shaping motion, allowing everything to rest into its place. Allowing everything to rest into its place as the larger story continues to unfold quietly. Beyond shaping galaxies, dark matter also influences the temperature of cosmic gas. In regions rich with dark matter, gas falls inward more easily. As it compresses, it heats up. This warmth can slow the formation of new stars, like a gentle hand holding back a rush, giving space time to settle before lighting another flame. It suggests that even creation benefits from pauses. In some galaxies, the distribution of dark matter appears smoother than early models predicted. This has led scientists to consider that dark matter may exchange energy through subtle interactions. Not collisions in the usual sense, but gradual adjustments spread across time, similar to how warmth moves through a blanket. No sharp edges, just a slow sharing. It is a reminder that balance can emerge without effort. On the scale of the entire universe, dark matter works alongside dark energy, while dark matter pulls inward with gravity. Dark energy pushes space itself to expand. The two coexist without canceling each other, one holding structures together, the other stretching the distances between them. I imagine this as a quiet breathing motion, in and out, holding and releasing, a rhythm that has no need to hurry. Measurements of the cosmic microwave background show tiny variations left from the early universe. These patterns reveal how dark matter was already influencing matter just a few 100,000 years after everything began. Those faint imprints still surround us today, like the echo of a sound that never fully fades, carrying information across unimaginable time. Closer to home simulations suggest streams of dark matter may flow through our solar neighborhood, remnants of ancient galaxies absorbed by the Milky Way. These streams move in coherent paths, passing through the disk like soft tides. They do not disturb planets or orbits, they simply pass. It is calming to think that even here, where days feel immediate and small, ancient currents are moving through unnoticed. As these invisible motions continue, they remind us that much of reality operates without display, without noise, without demand. Dark matter does not announce itself. Yet its steady presence makes long-lasting structures possible. And while you remain here, resting within layers of unseen influence, the universe continues its patient shaping, quietly arranging matter and space into patterns that feel almost like stillness. Quietly arranging matter and space into patterns that feel almost like stillness, as that patience extends into even deeper scales. Far beyond individual galaxies, dark matter influences how galaxy clusters grow over billions of years. These clusters are the largest bound structures in the universe. Their total mass is dominated by dark matter. By measuring the motion of hundreds of galaxies within a cluster, scientists can calculate how much unseen mass must be present to keep them together. Like watching leaves swirl in a wide, slow eddy and sensing the size of the water beneath. Within these clusters, hot gas fills the space between galaxies. This gas shines faintly in X-rays because it is heated by gravity as it falls into dark matter wells. The temperature of this gas reveals how deep those wells are. In a way, dark matter sets the thermostat of entire regions of the cosmos, quietly deciding how warm intergalactic space can become. It feels similar to how night air settles to a steady cool without anyone adjusting it. On even larger scales, dark matter affects how sound waves moved through the early universe. Before atoms formed, light and matter were tightly linked. Pressure waves traveled through that hot plasma. Dark matter anchored these waves, providing extra gravity that shaped their rhythm. The frozen imprint of those waves can still be measured today, like ripples preserved in stone long after the water has gone. Some models suggest dark matter particles move extremely slowly compared to light. This makes them cold in a physical sense. cold, dark matter forms sharp structures that allow galaxies to grow efficiently. If dark matter were warmer, those structures would blur. Fewer small galaxies would exist. The quiet coldness of dark matter allowed complexity to emerge, a reminder that calm conditions often support the richest outcomes. There are also ideas that dark matter could slightly influence the passage of time through gravity. Clocks tick more slowly in stronger gravitational fields. Inside dense dark matter regions, time itself stretches just a little. Not enough to notice, yet enough to matter across cosmic ages. It is gentle to imagine time flowing at subtly different speeds throughout the universe, each region resting in its own pace. As all these effects overlap and intertwine, they create a universe that feels stable yet alive. Dark matter remains unseen yet deeply involved, never speaking, never shining, simply continuing its role as the quiet framework beneath everything familiar. And while this invisible structure holds stars and galaxies in their long, slow paths, you remain here, supported by layers of calm, drifting comfortably within a reality that knows how to move softly. Within a reality that knows how to move softly, as attention drifts to how dark matter shapes change across time. One quiet fact is that dark matter halos continue to grow even now. They gain mass by slowly pulling in smaller halos and diffuse material from their surroundings. This process is gradual and uneven, like frost spreading across a window overnight. No single moment marks the change. Yet by morning the pattern is larger than before. It suggests growth can happen without effort or awareness. As halos grow, they can shift their shape. Simulations show many are not perfectly round. They stretch into gentle ellipses influenced by nearby structures. These subtle distortions affect how galaxies inside them rotate and align. I imagine this as a soft stretching of space, a slow adjustment that never snaps or strains, just a quiet accommodation to what lies nearby. There is evidence that dark matter influences the orientation of galaxies. Their spins are not random. They tend to align with the filaments of the cosmic web they inhabit. This alignment is strongest for smaller galaxies still closely tied to their dark matter environment, like leaves floating in a stream, turning gently to match the flow. It feels reassuring to know that direction can emerge naturally from surrounding support. Dark matter also plays a role in the survival of galaxies. When galaxies fall into dense clusters, tidal forces can strip away their outer dark matter halos. As this happens, star formation often slows or stops. The galaxy becomes quieter, redder, older. It is not destroyed. It simply settles into a different state. A reminder that loss can lead to stillness rather than disappearance. On the smallest known scales, dark matter may limit how tiny structures can form. Below a certain mass, gravity is too weak to gather material effectively. This sets a lower bound on the size of galaxies. The universe quietly chooses not to build endlessly downward, allowing simplicity to remain, like leaving empty spaces between notes so music can breathe. All of these influences overlap gently: growth and alignment, loss and restraint. Dark matter does not dictate with force. It nudges and shapes over long ages, and as these patterns continue to unfold around you, you can rest knowing that the universe itself favors slow change, subtle guidance, and a steady quiet that carries everything forward at its own unhurried pace. And a steady quiet that carries everything forward at its own unhurried pace as attention settles even deeper into the fabric beneath events. One gentle reality is that dark matter halos remember their past. Their internal structure reflects how quickly they formed and merged long ago. Halos that grew early are denser at their centers than those that assembled later. This memory is preserved over billions of years, like tree rings holding seasons of growth. The universe keeps its history without needing words. Within these halos, smaller subhalos continue to orbit. Some host faint dwarf galaxies, others remain completely dark. These subhalos can survive for a long time, even as they are slowly stripped by gravity. Their persistence helps explain why galaxies like the Milky Way are surrounded by many tiny companions. I imagine them as quiet satellites, moving faithfully, never demanding attention, just existing within a larger embrace. Dark matter also affects how matter cools and settles into disks. In spiral galaxies, the dark matter halo stabilizes the rotating disk of stars and gas. Without this support, disks would be more chaotic and short-lived. The calm rotation you see in images of galaxies depends on an unseen balance, like a steady hand beneath a spinning bowl, keeping motion smooth and continuous. In regions where dark matter density changes gradually, gas can flow inward along preferred paths. These flows help feed star-forming regions over long timescales, rather than sudden bursts. Star formation becomes a slow, sustained process, similar to a candle that burns evenly instead of flaring. It suggests that endurance often comes from gentle supply rather than intensity. There are also subtle connections between dark matter and the shapes of galaxy clusters. The distribution of dark matter determines where shock waves form in hot gas during mergers. These shocks leave faint arcs detectable in radio light. Even here, the invisible sets the stage for what can eventually be seen, like a breath-shaping fog on a cold morning. As these layers of influence continue to overlap, they form a picture of a universe guided more by patience than force. Dark matter does not rush outcomes. It allows structure to emerge through countless small adjustments, and as this slow guidance continues everywhere at once, you can remain at ease, knowing that deep beneath all motion there is a steady framework, quietly holding space, gently supporting change, and moving forward with the same calm rhythm you are settling into now. And moving forward with the same calm rhythm you are settling into now as the focus drifts toward even subtler interactions. Another quiet truth is that dark matter affects how light from the earliest stars traveled through the young universe. As the first stars and galaxies formed, they began to reionize surrounding gas. Dark matter shaped where this process happened first by guiding matter into dense regions. Reionization spread unevenly, like pockets of dawn appearing across a long night. The timing depended on invisible mass arranging where light could awaken. As this era progressed, dark matter continued to influence how radiation escaped galaxies. Dense halos could trap energetic light longer, allowing gas to heat and thin before photons slipped free. This balance helped determine how transparent the universe became over time. I imagine light patiently learning where it could pass, finding paths shaped long before by gravity alone. Dark matter also leaves an imprint on how fast structures grow at different epochs. By measuring how galaxy clustering changes with distance, astronomers can test whether gravity behaves as expected. So far, these patterns strongly support the presence of dark matter rather than changes to gravity itself. The universe gently confirms its own rules through repetition, like a familiar melody returning again and again without surprise. There is evidence that dark matter halos can oscillate slightly after mergers. Not violently, just slow breathing motions as gravity redistributes mass. These oscillations can subtly influence the orbits of stars near galactic centers, creating faint asymmetries that persist for millions of years. It feels similar to how water in a bowl continues to sway long after it is set down, motion lingering softly. On intergalactic scales, dark matter helps determine where cold gas filaments connect to galaxies. These filaments act as supply lines, feeding galaxies with fresh material across cosmic time. Without them, galaxies would slowly fade as their gas is used up. Dark matter keeps these connections aligned, maintaining quiet channels between vast distances. A reminder that nourishment often arrives gently and continuously. As these processes unfold together, they reveal a universe guided by subtle coordination. Light and matter responding to an unseen framework that neither commands nor rushes. Dark matter continues to shape the conditions for change rather than the change itself. And as this deep structure holds steady around you, it becomes easier to rest within the idea that support does not need to announce itself. It can simply be there, constant, patient, and softly present beneath every movement. And softly present beneath every movement, as the attention no longer needs to follow those ideas anywhere. They can rest now. The universe keeps its patterns without help. Dark matter continues its quiet holding, whether it is noticed or not. You do not need to trace it anymore. You can simply allow the sense of steadiness to remain. The images can begin to blur gently, filaments and halos fading into a single calm impression. Not many thoughts, just a feeling of support, like lying back against something wide and patient. Nothing pulling, nothing asking, only a slow ease. Breath becomes simpler. The mind does not have to reach outward. The vast structures we wandered through settle into the background, like distant stars when clouds pass in front of them. Still there, just quieter. There is space now, soft and unoccupied, a place where thoughts can drift and dissolve. No need to name anything, no need to remember details. The universe does its work on its own time, and you can rest inside that trust. The sense of motion slows further. Words thin out. Meaning becomes gentle and broad, like warmth spreading evenly, like night air settling. Nothing more to follow, nothing more to hold. Just calm, just rest, a steady quiet, carrying you gently, supported, unhurried, and in this softness, everything is allowed to slow. You can let go now.